Le Chatelier's principle states that if an external stress is applied to a system at equilibrium, the system adjusts in such a way that the stress is partially offset. The words iron 3-thiocyanate, which is FeSCN3, dissolves readily in water to give a red solution. The red color is due to the presence of hydrated iron thiocyanate ions, FeSCN2+. The equilibrium between undissociated iron thiocyanate ions, iron 3+ ions, and thiocyanate ions SCN- is given by this chemical equation. FeSCN2+ aqueous, which is red, in equilibrium with iron 3+ ions, which are pale yellow, plus SCN- aqueous, which is colorless. In this case, the stress applied to the equilibrium system is an increase in the concentration of thiocyanate, SCN-, from the dissociation of sodium thiocyanate. To offset this stress, some iron 3+ ions react with some of the added thiocyanate ions, and the system shifts from right to left to re-establish equilibrium. When the system shifts to the left, iron thiocyanate ions are produced, which have a red color. Consequently, the red oxalic acid ionizes in water to form the oxalate ion C2O4 2-, which binds strongly to the iron 3+ ions. Free iron 3+ ions are removed from the solution as the stable yellow ion iron 3 oxalate is formed. The system shifts from left to right to replace some of the iron 3+ ions. You have increased the pressure by decreasing the volume of the container. The system can partially offset this stress by decreasing the moles of gas. Recall that pressure is directly proportional to the moles of gas. You have decreased the pressure by increasing the volume of the container. Le Chatelier's principle states that this stress will be partially offset. The system can partially offset this stress by increasing the moles of gas. Pressure is directly proportional to the moles of gas. Because of the 2-to-1 mole ratio, consider the following reaction at equilibrium. You have increased the temperature of the system by adding heat. Le Chatelier's principle states that this stress will be partially offset. This reaction is endothermic, so you can think of heat as a reactant. Heat must be supplied to the reacting mixture. You have decreased the temperature of the system by removing heat. This reaction is endothermic, so you can think of heat as a reactant. Heat must be supplied to the reacting mixture. The system can replace some of the heat that was removed by shifting to the left, producing more N2O4 and decreasing NO2, as you can see in the microscopic view.